Hello, everyone, and welcome to today's webinar presentation, Automation for Kubernetes Clusters, sudoRy, a Kubernetes Executor, brought to you by NexClipper. I would like to introduce you to our presenter. Jerry Lee has 25 plus years of experience as an executive for startups and Fortune 500 companies, leading digital transformation and global operations in the private and public cloud sphere. He has been with IBM, Accenture, T-Mobile, Korea Telecom, DZS, and Forever 21, and is currently head of product at NexClipper. And now, without further ado, Jerry, I'll turn it over to you.
Thank you. Thank you for the introduction. Hi, everyone. This is Jerry Lee, leading product engineering at NexClipper. Today, I try to introduce our new open source project named sudoRy, automation for the Kubernetes cluster. So before deep dive into the story details, let me just introduce what NexClipper is doing. NexClipper is a startup for machine learning operation and observability for Kubernetes. We had a plan to launch the beta services of machine learning operations and Kubernetes observability beta Q4 this year. And we actually launched the sudoRy open source project early this year. How was sudoRy born? We're actually looking for solutions to automate the management of Kubernetes cluster. It doesn't matter like which cloud services we have to use or how many clusters we have, because we want to support our customers' cluster, Kubernetes cluster more autonomously. We want to manage them. We want to help them out to execution of like services. So we were looking for the right solution, but unfortunately we couldn't find the right solution for us to have that kind of like capability. And also like searching for a new way to reduce the operation hours in one by standardized like Kubernetes operation. So this is the kind of motivation for us to develop the sudoRy project. Then what sudoRy can do? What is the sudoRy? So sudoRy is technically remote Kubernetes executor to maintain and manage your Kubernetes cluster with the standardization and automation by just RESTful APIs. So for instance, like sudoRy can do collect the Kubernetes events, or like get volume usage of the pod, or edit config map and then redeploy the application, install, uninstall application by Helm operation, or you can like modify the Helm, or collect the Prometheus metrics and alerts and rules. There are so many APIs you might need to access and use to maintain your Kubernetes cluster. sudoRy can make those API access standardized so that like you can reduce the operation hours and improve your productivity to maintain your operation. Let me just briefly show how sudoRy works. So first of all, you must have like sudoRy solver in one of your Kubernetes cluster somewhere. And then let's have the assumption that like you have like multiple like Kubernetes cluster running on each like CSPs like AWS, Azure, Google Cloud. It doesn't matter which cloud the service provider you use, at least like you use like Kubernetes. Then what you need to do, you just like need to install like sudoRy client in each cluster. Then everything will be maintained. So for instance, once you just install a sudoRy client, you start pulling service requests to the solver by defining the time frame. It can be like 3 seconds or 5 seconds. sudoRy client keep connecting to the solver and then ask the question, like, do you have any services for me? So this is like given like environment. Then user can submit the service request to something they need to do. For instance, I need to get the Kubernetes event list. Then they just need to access the solver saying, I need a like Kubernetes event list for a specific cluster. That's all what you need to do. Then sudoRy server will create it and push the service request so that like client can be access the service request. Then like the cluster will execute the specific request and then return the response back to the solver. Then sudoRy server will create the return message and send back to the submitter. That's how sudoRy works using the solver and client maintain your Kubernetes cluster. Then let me briefly list up what I'm going to show you to set up the solver and client to use the service request. By the way, this is the link of the story manual, so you can access the specific link. You can get the story manual how to use it. So we'll show like how to set up the story solver. Then like we'll show how to register your Kubernetes cluster into the story solver. And then you need to install like story client to your Kubernetes cluster. Then register channel. Channel is your destination that the story needs to deliver the response back to you. And then finally send the service request from the user to the story solver. And then we'll show some integration example. So our NexClipper applications, the first user of the story open source project. So we'll show how storage solution can be integrated with some application services like this. Okay, to install storage solver, you need to have the MariaDB as a prerequisite. The version should be in the 10.x and above. There's a Helm script. You just need to run those Helm scripts. Then you should be able to install the MariaDB. It's simple and very easy. So this is very typical example. You just run the Helm script, then yeah, boom, MariaDB can be installation. You can see one more time. Just type in the cut and paste the Helm script up there, then you can get the MariaDB done. And then we'll show the storage server installation the same way. You just need to register Helm repo of our NexClipper. And then this is Helm script. If you look at the Helm script, it's quite straightforward. And then you just use the story as a username and story as a password for the MariaDB setup. You just need to set up exactly the same username and password here. The rest of the process will be taken care of by the Helm installation. So you can cut and paste the script I just showed before, and a Helm installation will be complete very soon. So you can definitely get like the pod under the story namespace. There's a pod that's running. Then you can log what's happening in the pod. Then you will see that okay, this is the way they show the story successfully installed. Next one, you need to register Kubernetes cluster you want to manage by the story to the story solver. So the very simple RESTful API host solver cluster. In the body, you just need to put the name of the cluster, and then you have to put like those two different options. The first one is a polling limit, which is like in case I assign the service request, then story client need to pull service request from the server. Then when one trial of the polling the service request, the max limit is 10. You can definitely increase the limit to 20 or 30. It should be okay, unless like the operation, the service request is quite heavy one. And then the other one is actually polling option. So story client is actually async-based operations. The client can access its solver every 5 minutes or 10 minutes as defined. So in case of regular, then you can just set up like 5 seconds or 10 seconds. Then it will start like accessing your cluster, your solver every 10 seconds. But in case you just set up it smart, then like in case of busy time, use 5 second time period. But in case idle, not much work to do, then this will slow down to reduce the computing resource. And then like in the idle time, it's like if we set up like 15 seconds, then it will access the software every 15 seconds. So we'll show how to create it, how to run those like post the API. So very simple. You just like populate the name, the body, and then polling option. Just run it, then you can get the response. You need to remember, like in case you just run the API, then it will deliver the UUID of the cluster. So you just need to cut and paste those information for the next operation. Then next one, it's about the global variable. Once you set up the cluster, there are several variables you can configure. So like I just mentioned, in case you want to change the polling interval from 2 seconds to 5 seconds or 5 seconds to 50 seconds, default polling interval is 50 seconds if you don't set up anything. But if you want to make it shorter, then you can definitely change the specific interval time to like 5 seconds or 2 seconds or 1 second. Then polling interval will be shown. Also, there's a client config log level. Default is debug, but you can definitely change. And also, like session expiration time, default is 60 seconds. It can be increased and decreased. It's a configuration point right there. You can just run to run those put API. You probably need to get like UID of each API. So what you need to do, you just like need to run the get API so that you can get a bunch of like the parameter. Then like you definitely see the UID of each parameter. Then using the parameter, you can run the put API. Then you can update it like specific API, the variables information. This is about the changing the global variable. The next one is the installation of the stored client. So if you want to install the stored client, first of all, like you need to get the token by running the server token cluster API. So you just need to provide it a UID, and then in the body, you then post it, then you will get the token. But this is, for example, this UID, then the result, you can get the token. So you just need to get the UID and token, then you definitely can register client. Then once you just get the UID and token, and this is your stored server's location, you can create the client by this Helm script. So remember, you just get the token from previous slide. Also, you can get the cluster ID when you register cluster. Those two information need to be populated. Then you can run this Helm script. So this is the way of the installation of the Kubernetes cluster client. So this is Helm script to install the client. Then the install client install. Then you can definitely check the part of the stored client namespace. Container is creating. You can check that out. What's happening in the log. Then you can see the handshake to the server. Then your stored client is set up. And then, as I explained before, you need to have the channel to receive the response from the server against your service request. So first of all, you need to register. Channel by the post API. So you just need to provide a name of your channel. Then it will give you the UID of the specific channel. Then you can register like channel details such as webhook. So currently we support channel details as a webhook, console, RabbitMQ, Slack. There's 4 different types of the channel you can set that up. So once you get the channel's UID, then using the UID you can run the put API. For instance, this is one of the example of the webhook the channel registration. Just provide a webhook URL in the method. Then that's it. That's all you need to set up to configure the channel using the webhook. Then you just need to place the service request. So like we actually provide around 180 stored template to create a service request. So one of the example is like Kubernetes pods execute, so you can access the pod details. Then we actually use a channel. The template ID is 35. And then we just created the webhook channel. The name and like summary. Then this is the cluster UID, And this is some more information to get the details. Like for instance, this service request try to access those specific part under this namespace, and then we want to run this command for pulling some information by the Kubernetes part execution. So this is the way of the configure your service request, and then use this post API, then you can get the response back. So this is like overall explanations how you can set up the story client and solver and cluster and channel, and then you're ready. Then you can use those like story itself, or you can integrate the story with your application. So today I'm going to share our own application named the NexClipper Observability and how we use story as an integration tool. So this is our user interface of the application. As you can see, there are multiple like Kubernetes cluster. This is from Google, this is the Ocean, this is AWS. So this is the cluster, Kubernetes cluster registered by story. But let me just quickly show how you can register cluster. Just provide a name, such as like some test cluster. Let's say this is like Google Cloud. Then you will see the Helm script to install story client, exactly the same one I showed before. This is the way how you can create a story client. What you need to do is just like cut and paste those Helm script and run against running your Kubernetes cluster. Then story client will install. Then the cluster will be helped by story client. But this is how you can install a story client. Then once the story client is installed, so what you can do as a next topic, you can do several things with the cluster. So since like we already integrate the story API with our application, this is to what we develop using story. So for instance, in case you want to get some volume usages from your cluster, it's one of the part. So I'll pick it up one AWS staging, and then I can get some. I can select some specific part template, and then let's say like there's a namespace VM, and then this is the one of the part we have. This is the preset, have some volume, so I picked it up the specific the part name under those namespace. And then yeah, so this is I want to run the df-h to secure the volume usage information, and then just submit it. Then yeah, submission successful. Now the server get the request the client run it, send it back. Now I got the response from the system. It says total volume is 15.6 gigabyte, but then the usage only 2%. How easy is that? Like to get that volume usage details, I can just like run those story APIs and able to get the response back. And then those response, I set that up channel in advance, so I able to receive the story response to the specific webhook, so able to show those information. Also, I can do so many things as this explained. We support around like 140 and I plan to extend the APIs to 200, including Kubernetes API in Helm or Prometheus. So we'll show a little more. So try to show some Helm value. Once Helm installation is done, then you definitely can access the Helm value. So let's say I try to get the Helm value. So this is the Helm value. Just like provide a namespace. And then this is one of like instance name of Helm installation. Submit it. Then talk to the server client and send the response back. Yeah, this is the I just received from the server. This is the Helm value of like Prometheus stack installation. So you can see the Helm value like alert manager, And also for DNS, Visual Exporter installation and default rule. There are so many Grafana, so a whole bunch of the hand value can be pulled very easily. And also we can update the hand value. So for instance, using desktop, we actually set up some configuration screen. So if you just like pull the hand value, then I just show you like there are many hand values can be captured. But then like this is the highlight of like Prometheus hand value. The retention period 8 days, scrap interval 1 minute. So let me just change the scrap the retention period to 5 and save it. Then it'll go to storage servers and client to run the Helm update from 8 days to 5 days. So let me see what the response now is processing. So Helm processing, then it should be done within a minute. But this is how you maintain your cluster without go and console run. Then you have to teach the people how to do it. Instead, you can just like integrate the through API with your application. Then everything can be like automated. Now it's successful, which means now hand value updated from 8 days to 5 days. Then what we can do, we can pull the hand values again to make sure now retention date is 5 days. This is how you can update it for validating your Kubernetes cluster. So let me just come back to the presentation slide and briefly cover what's the benefits out of this story implementation. So as you can see, you can definitely standardize your operation, Kubernetes operations such as like Kubernetes API based or Prometheus API based or Helm API based, so that you can minimize the human error. And also you don't need to train your DevOps people to how to use a Kubernetes cluster that detail. And also this is all reusable template. You can execute the same template against the multiple cluster. Also it's API driven. You can make every operation is automated. Definitely you can lower operation costs and can support at scale. And from the security perspective, it's the async operation. There's no such access from the external to your internal like Kubernetes cluster. Always store client try to come out to find out what you need to do, execute it, and return the message back. And also you can control story client privilege by cluster role in the Kubernetes. Is more like native way of access control rather than having their own application where you have to trust the one. No, actually, story client can be controlled by cluster role. The roadmap, we had a plan. As you can see, the story client can be installed a lot of like Kubernetes cluster. But for now, you have to access the cluster one by one. So what we're going to do, we're going to create the concept cluster group so that by running one service request to the group, then multiple like cluster can process the request and send back to the result back to the solver. So that's what we try to do by this year. And also there's a multi-step support we was thinking of. Like for instance, you can get some information and then you need to update something and then you need to redeploy. There's supposed to be a lot of the steps to operate your Kubernetes maintenance work. So for now, like one template and one step. But what we're going to do, we're going to support the multi-steps with the workflow so that you can configure, you can branch out operations by multi-steps. That's actually planned by next Q1. And then eventually, like we want to provide us some management UI. You just see Executor, the maintenance pages by NexClipper. We developed the UI, but what we're going to do, we're going to port that user interface back to the story so that it can be a fully open source, up and run, and maintain your story client, story server environment using the GUI, including workflow. That's pretty much it for today's presentation. Hope you guys enjoyed the presentation. In case you have any question or comment, feel free to reach out to me by this LinkedIn profile and send an email, jerry.nexclipper.io. I'll be happy to answer.
Thank you, Jerry. And we do have a few questions from the audience. So would you like to go ahead and start with those?
Yes.
Great. So the first question we have from an attendee, how many sudoRy clients, Kubernetes clusters can be supported by a single sudoRy server?
So technically, there's no limitation. So we benchmark, we actually tested it up, like how many the service requests can be covered within a minute, and we don't have any issues by around 1,000 to like 2,000 service requests per 1 minute. So hopefully it can be the answer. So my answer is like there's no limit.
Great. Okay. Next question we have here. What's the recommended poll interval from client to server?
So while you saw in the demonstration, we actually use 5-second interval. So like 5 seconds should be enough for the visit time, but in case non-visit time, you can set up as a 15-second, which is smart mode will be the right choice.
Okay. Great. Our next question is how are the channels supported?
Yeah, I've briefly covered the one. We support as of today the webhook, the RabbitMQ, and Slack, and client console. We had a plan to extend other channels such as Microsoft.
Great, great. Next question is a two-parter. First part is this only for Kubernetes environment, and are there any plans to support other platforms?
That's a good question. We've been receiving that question quite many. So we, as of today, only support Kubernetes, but we had a plan to extend the study client to OpenStack and bare metal. Hopefully, we can deliver by Q1 and Q2 next year.
Great. We have a couple more here. Does sudoRy server support high availability architecture?
Yes, we do. But there's a database HA solutions required, so recommend to use a MariaDB HA solution. Oh yeah, we do support high availability option.
Great. And Jerry, it looks like we have one more question, and it says here, does sudoRy client support TLS connection to sudoRy server?
Today we actually use only like XAuth in the header. This is the only way to provide authentication. But yeah, we had a plan to support a TLS by early next year.
Okay. And it looks like that is the last question of the day. So, Jerry, thank you for your presentation and thank you for your contact information there.
Thank you.
With that, DZone would like to thank Jerry Lee for an outstanding presentation. DZone would also like to thank NexClipper for providing the audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Thank you.